Okay, hello everyone. I'm making a video for Project 2 Part A, and it may look slightly odd with the chat window because I scheduled the video ahead of time as a live stream just so I could get the link ahead of time rather than waiting until I was done and uploaded before I had the link to put in the project spec. So I'm going to talk today about Project 2 Part A, the galaxy simulation, and this one is going to be predominantly about Part A. There's going to be a little bit at the beginning here about A and B, and then we'll switch over to Part A entirely. Now, first thing is, for the Part B, there's going to be another video. There's a link. I'll try to remember to put the link in there. It's also in the project spec. And there are going to be two different parts that you submit, two different entries on the autograder to submit to. So there's going to be a Part A galaxy simulation. There's going to be a Part B priority queue. Each part allows you 2 submits per day. If you find enough bugs on Part A, you will earn an extra submit per day for Part A only. Also, if you submit a late extension using one of your late days for either part, it will extend both parts. So you don't have to use like 2 days to get 1 day. You use 1 day for one part. It doesn't matter which you enter it in. It'll give you an extension for the other part. Now, for the overall project, I would suggest, obviously at first, start learning and reading about it. Don't try to finish one part before you understand the other part. So start reading about the galaxy simulation, start working on like understanding it, reading input, making test files, submitting test files for Part A, but also start understanding Part B. In Part B, you're going to have the sorted PQ that you have to implement is going to be pretty easy, and there's a whole other video for this, but there's going to be Part A is pretty easy, for Part B, one part of it is sorted, is pretty easy, another part is binary PQ, which is mostly translating the slides, and the third part is pairing heap, which you're going to have to read a paper and turn it into an implementation. So don't try to finish one part before you start the other part. Be willing to go back and forth. Oh, I'm stuck on Part A. Well, I'm going to go get some work done on Part B, and vice versa. Because if you leave, like, say, 10 days where you're just working on Part A and don't even start Part B, that's 10 days of submits for Part B that you never submitted. So it doesn't mean you have to submit both parts every single day, but don't waste every day on it while you're working on just one part. Okay. Another part that's important, another topic that's important for both parts here is functors. So because we're going to be dealing with priority queues in both parts, you're going to have to deal with functors. In Part A, you're going to be dealing with the external view. Like, I wrote a functor and the priority queue of the STL uses it. In Part B, you're going to be taking sort of the inside view, like I am the priority queue and somebody gave me a functor and I've got to make sure that when they ask who's on top that I show them the right highest priority element. But in both parts, it's important to understand what a functor does. So a functor for priority queues is always going to have 2 parameters. We could call them A comma B. We could also call them left comma right. Names aren't important. What's important is the question that the functor must answer. So the functor always has to be able to answer the question, is the priority of A less than the priority of B? So a functor always has to answer that. So like in Part A, you've got to have one priority for Sith and a different priority for Jedi. you will have two different functors, and they will make their priorities calculation in a different way. They will break ties the same way, we'll talk about that in a bit, but how they determine priority will be opposite for the force values. Okay, so let's talk about Part A stuff specifically. Okay, so Part A, we've got to do the galactic simulation. One thing that's important about this one is there's a flag -v or -- verbose. You want to implement this all the way through the project because it's going to help you debug. And it's just a matter of like, if verbose mode is on, I have a cout, and there's no else. So if you don't implement verbose mode and you get to you implement everything but verbose mode and you get wrong values, you don't know why. But if you have those values, those verbose things printed, you would get an idea of where it went wrong and when things changed. So work on that as you go through. We'll talk a little bit more about the other three modes later. Okay, so now when we start doing the simulation, we've got to match the highest force Sith with the lowest force Jedi. So the highest force Sith, think of it this way. The Sith are kind of cowards. They only want to fight not only when the odds are in their favor, but then when the odds are overwhelmingly in their favor. So if you had, for instance, on a planet, there's a Sith with force sensitivity 10, and there's a Jedi with force sensitivity 20, the Sith will hide behind a rock and he won't even let the Jedi know he's there. He will not fight. So it's a matter of priorities if there's multiple Sith. So if, let's say, there was multiple Sith, there's a Sith with a force 10, there's a Sith with a force of 30, and there's a Sith with a force 100 there. If all three of them are there, the one with the highest force, Sith, would fight the Jedi. Oh wait, which Jedi? Let's say there's two of them. There's another Jedi with a force sensitivity of 25. The highest priority Sith is the highest force sensitivity. The highest priority Jedi is the lowest force sensitivity. So Jedi are very brave, possibly foolhardy. So even though her force sensitivity is the lowest, she's the one who charges into battle first. She's the one who has to prove that she can take this Sith out. So we're going to have two different priority queues, right? If we throw them all into one priority queue, then we can only say this one's on top. Well, who do they fight? I don't know. They're hidden in the priority queue down below that. So we got to have two priority queues, one for Sith, one for Jedi. They will have different functors. Should we make two different types of deployments, a Sith deployment and a Jedi deployment? No. Make one type of deployment and two different types of functors. Now, so we got to have a separate priority queue, one for Sith, one for Jedi. But wait a minute. What if the highest force Sith and the lowest force Jedi are on different planets? Then they can't fight. But maybe let's say this one is on planet 1, this one's on planet 0, this one's on planet 0 also. So, hey, that Force 30 Sith is willing to fight that Force 20 Jedi, but that Force 30 Sith is not at the top of the PQ. We need more priority queues. We don't need just a Sith priority queue and a Jedi priority queue. We need them on a per planet basis. So think about this. We got to organize our data, right? I think I should have, besides like a deployment and a highest priority Sith and a higher priority Jedi functor. So there's three types so far. Deployment type, Sith priority, Jedi priority, planet, because I've got to keep track of all this stuff on a per planet basis. Well, right now, a planet has 2 priority queues, but maybe when we implement some other stuff, we'll discover that a planet needs more things with it. So if I were to make a planet object, put those 2 priority queues in it, and then make a container, a vector of planets, then later on, if I discover, oh, a planet needs more stuff added to it, I can add more member variables. I might add more member functions to the planet class. So we're going to have to keep 2 priority queues per planet just to make battles happen. Now, when you read things in and you store it in that deployment structure, you want to make sure it's efficient, though. Because if I read in a string containing Sith, the string, or Jedi, the string, do I want to store a string in my deployment object? No, that would be kind of a lot of space. I mean, a string is like 32 bytes minimum. So I don't want to compare strings if I don't have to. I want to say, hey, I read in Jedi. I've got a deployment that's holding a Jedi. Oh, let's put it in the Jedi priority queue. So once it's in that priority queue, if you're in the Jedi PQ, you must be a Jedi. You don't need a piece of data to say that. So if you're in the Jedi PQ, you must be a Jedi. If you're in the Sith PQ, you must be a Sith. So I have to read that in, but I don't necessarily have to store it with the deployment. What about the planet number? If I'm in the Planet 0 Sith priority queue, I must not just be a Sith, I must be on Planet 0. So there's going to be things you read in that may or may not have to go into a deployment. Okay, what if 2 deployments have the same force sensitivity? So let's say we'll just erase those. Let's say we're dealing with some different planets. So I've got a force 20 on planet 5, and I've got a Jedi with force 20 on planet 5. They will fight. So if they have the same force sensitivity, that's still, the Sith is still feeling like they got a decent shot at this, so a fight would happen. But what if there's another force 20 on planet 5? And also, there's one thing I've showed you before this. There's also a quantity. There's a number of them. So let's say there was a number sign 10 of these, number sign 2 of these, number sign 5 of those. So a fight will occur. In fact, more than one fight will occur. The question is, and which one comes first? Let's assume that the Jedi arrived first. The 2 Jedi arrived, then 5 more Jedi arrived, and then a Sith arrived. Well, now a battle can happen, but the question is, which one of those Jedi fights? The answer is, whichever one came first. So everybody's equally polite in this way. So if there had been 2 Sith who arrived at first time, Sith are also polite. The first Sith with the same force sensitivity has a higher priority. So being there earlier helps. Now, wait a minute. I've also been drawing this without timestamps. Oh my gosh. What if these were, it's in a different order, but we'll put it at the end here. What if this was timestamp 3 and timestamp 3? Oh, wait a minute. Now, the timestamp doesn't help me make a decision to break a tie. It might need to be in there for other reasons, but it does not help me break a tie because the timestamps could be equal also. So, whose fault is this? So think of it this way. I'm the functor, right? I'm inside of priority underscore, I'm in your code, and I get used by priority underscore Q. Priority underscore Q calls me and says, here's 2 things, these 2 right here. Here's 2 things. Which one is the priority of A less than the priority of B? And I must say true or false. And I have to make a decision. Now, if there's not enough data there, it's not my fault. I'm just the functor. It's not the priority queue's fault because the priority queue fault just put stuff in that was in there. So if there's not enough information in there, that's your fault, the coder. You've got to add into a deployment enough information to make that decision. So if sufficient information isn't in there, you're going to have to add it. You're going to have to add something that can break a tie. Think about let's call it an ID number. If everybody had a unique ID number, then we'd have something we could break ties on. Okay, so I think that's the basics of our galactic simulation. Like I said, get the verbose mode going as you work on it. Then there's a few other modes. So general info mode. Now general info modes, all the info on that's going to be in this video. Some of the other modes we got separate videos for them. So in the general info is pretty easy. One thing about it is there's going to be general info. The number of generals might be different from the number of planets, and they don't have anything to do with each other. So like I could be General 7, I might issue troop deployments to Planet 0, Planet 3, Planet 12. So you're going to need like a vector of planets, like we said earlier, and a vector of generals. Now, when you read the command line, do that first. When you start reading the file, and it'll tell you how many planets there are, how many generals there are, so you can resize your vectors up front. But if general evaluation mode is off, I don't really need to resize the general's vector because I'm never going to look at it. So, but if general eval mode is on, then that vector of generals would get resized. The vector will always exist, but only if general eval mode is on do we resize it. An empty vector doesn't take that much room, about 24 bytes. A pointer, an allocated memory size, the capacity, and the current size. So it's about 24 bytes for an empty vector, no big deal. The general eval mode is basically you keep track of how many troops a general deployed, how many troops, I think you can do it a couple different ways, but at the end you have to print out the general eval. I should have looked this up first. Now I got to look it up on here because I can't remember the exact output. Okay, yeah, so it's how many Jedi and Sith this general deployed and how many total survived. So it is possible. It is possible that there's generals that we don't know, that we think the generals are on our side, but hey, maybe they're doing deployments for the other side also. So you keep track of how many Jedi were deployed by this general, how many Sith were deployed by this general, and at the end, you have to somehow be able to output how many survived. So you either have to keep track of either how many are still alive or how many have died. Either way, you can get the result at the end. Okay, so that's the general eval mode. Median mode. So median mode is keeping track of, along the way, what's the median number of troops that have been lost on a given planet. Ooh, that sounds like whatever I do to make a median, I'm going to have median data in every planet. So my planet structure had the priority queue for the Jedi, priority queue for the Sith, and it's going to have data for median mode. Now, if median mode is off, that variable or variables will still exist. We just won't fill it up with data. That's okay, not much wasted. Even though it's on a per planet basis, still not a big deal. There's a whole nother video for fast running median mode because we use it in several different projects with several different themes. So there's a separate video for the fast running median that I'll put a link to when I'm done and this is uploaded. Okay, last thing that we're going to talk about today, which is another mode, and it is going to stay in this video, is Movie Watcher. So Movie Watcher mode is a little bit hard to understand. Think of it this way. Here's our basic description. You are a very avid Star Wars fan, and you want to watch the movie, and you're going to write down a few notes about this planet that you're most interested in. So if Movie Watcher mode is on, there would need to be a separate movie watcher for each planet. So you're a movie watcher, you are watching, say, Planet Zero is your most interesting planet. So you're watching Planet Zero, and what you're trying to do is you're trying to keep track of the most interesting attack or ambush that could have happened. We'll talk about what those are in a minute. Now, one thing about it is you cannot bring a laptop with you to the movie theater and have it shining in the eyes of the people behind you. That's very rude. So you have to just bring a notebook and write things down with a pencil on your notebook, and you have basically O of one space. Okay? And remember, you're a per planet. So you have basically, as the movie watcher, per planet, you have O of n time and O of 1 memory, where n is defined as the number of deployments to your planet. Okay, so you've got a fixed amount of memory, and you've got you can only spend a fixed amount of time considering each deployment. Now, what we're going to do is we're going to discuss attack mode. Attack mode is when a Jedi arrives first and a Sith arrives after that. They could be the same timestamp, but just we're talking like sequentially. There has to be a Jedi on the planet, then a Sith arrives, then the Jedi attacks the Sith. In ambush mode is the opposite. The Sith arrives first. And what we're going to do is we're going to run through a big example using attack mode as our example. And what we're going to keep track of is some important data, but more importantly, we're going to keep track of our state. And this is a really, really powerful tool. It's really important for some things. And what we're doing is called a state machine. So we're going to keep track of what state we are in. If you don't keep track of what state you are in, you can still do this, but the ifs will be much more confusing. So we're going to have 4 states, and I'll add the states in as we go through the example. Okay, so I got to make sure I've got enough room. Okay, so I'm going to give a timestamp, which doesn't really matter, Sith or Jedi, and the Force sensitivity, because that's all that really matters for our movie watcher. Okay, so let's say timestamp 0, and this is all, and we're restricting ourselves to our planet 0. We're just assuming I'm only looking at the planet 0 ones. So at time 0, a Sith arrives. I'm just going to write S. I don't want to write Sith and Jedi for every one of those. Okay, so I've got a Sith arrives with a Force sensitivity of 50. And the question you have to ask yourself for every one of these deployments that you see is this deployment interesting to you? Now, you are a movie watcher who's paying attention to attack mode. This isn't interesting. It doesn't matter if there's a Sith. It's when there's a Jedi who arrives, and then at some point after that, a Sith arrives. So this one is not interesting. Now, what we can think of in our state machine is I am in my initial state. I'm in my initial state, and if I see a Sith, I don't change anything. I don't change my state. I don't change any values at all. I just stay put. Okay. Timestamp 1. A Jedi arrives with Force 50. Is that interesting? Yes, it is. That's the start of the interesting stuff, is that I'm not in my initial state anymore where no one's arrived, and we could rename this state if we want to. Instead of calling it initial state, we could label it no one here, or whatever you want. So we've got our initial state. When we see that Jedi, I'm going to remember, I've got to remember the time stamp and the Force sensitivity of this Jedi. And I'm going to have to change my state. So my state is going to change to let's say, let's call it the Cena Jedi state. Okay, I'm in the Cena Jedi state. I made a state transition. How did I make a state transition? I have a variable which changes its value to tell me what state I'm in. We'll talk about what kind of variable in a few minutes. All right, so I got my initial state, I've got my transition to my Cena Jedi state, and I've got to keep track of this one. I've got to keep track of the fact that I've got a Jedi with Force 50 at time 1. All right, now, next deployment, time 2. I see another Jedi with Force 40. Question is this interesting? Yes, it is. It doesn't cause me to change state, but remember, I'm interested in the most exciting fight, right? The most exciting fight is going to be the lowest Jedi with the highest Sith arriving after that. So this one is in fact so interesting that it will replace the old one. I don't need extra variables. I just update my variables. I say, hey, I'm still in the same state, but instead of a Jedi with Force 50 time 1, I've got a Jedi with Force 40 at time 2. So I update my best Jedi's Force and my best Jedi's time. Okay, now, time 3. Sith appears with Force 20. Is this interesting? No, because when this Sith arrives, this Sith will hide behind a rock and will not fight because that Jedi is more powerful. No fight happens. So that's not interesting to me. From a movie watcher, it's boring when the Jedi or when the Sith hides behind a rock. Okay, so next time, time 4. Time 4, I get a Sith with Force 80. Is that interesting? Yes, it's very interesting because I now have a pair here. I've got a Jedi arrived at some point later. These could be all timestamped too. It wouldn't matter. But it's arrival first. So there was a Jedi arrived. After the Jedi arrived, a Sith with a higher, equal to or higher Force sensitivity arrived. So now I've got to make a transition to a new state where I've seen both. And I would have to keep track of both. I'd have to remember, oh, my best Sith has a Force sensitivity of 80, arrived at time 4. Okay, so that caused me to do a state transition and update a few variables. All right, now, time 5. Let's say a new Sith arrives with Force 100. Is that interesting? Yeah, that is. Oh, wait, I forgot a state transition. You've probably been noticing that. I forgot it. When we went from Jedi to better Jedi, we stayed in the same state. We didn't change states. That transition occurred because we had a better Jedi. This transition occurred because we had our first Jedi. And this transition occurred because we got our first Sith that would cause a fight. Okay, so now when I see this new Sith, hey, I've got a better potential fight here. Instead of a potential difference of 40 to 80, which was 40, so this used to be a difference of 40, but now I've got a potential fight with a difference of 60. A difference of 60 is better. So what I'm going to do is I'm going to stay in my same state, but I saw a better Sith. So I'm not going to change state, but I'm going to update my best Sith is Force 100 at time 5. Not 80 at time 4, 100 at time 5. So we forget that one, we remember this one. Okay, now here's where it actually gets tricky. Okay, time 6. We see a Jedi arrive on this planet with a Force 10. Is that interesting? Well, if that force 10 could attack the force 100, that would be really interesting, but that can't happen. This Jedi can only be matched up with a Sith who arrives at some point afterward. So I can't replace my best Jedi, but this could potentially be a more interesting fight. So I've got to remember it. I need a new state. I'm going to have to transition to a state where I've got a maybe a better Jedi. So I've got this new state. I transition over here because I saw a better Jedi. Now, if the movie were to stop at this point, I would print my 60 pair between this one and this one. I would say, hey, a movie watcher would like to see an attack on Planet Zero with a Jedi at time 2 and a Sith at time 5. So if the movie were to end here, I've got to report the old pair. But I've got to remember, hey, at time 6, there's a Jedi with Force 10 who might be better, so I need a couple of variables for that. I've got him on my maybe Jedi. Now, what happens if I saw at time 7, I saw Sith with Force 70? Okay, so that one was potentially interesting. Now, the Force 70, that would be a difference of 60, but I've already seen a difference of 60. You go with the earliest one. So if there's a tie on the difference, you always go with the earliest one. So that's not interesting. Okay, at time 8, I get a Sith arrives with a force of 80, and now that's strictly better. That's a difference of a 70. That's more interesting than 60. So what I'm going to do is I'm going to transition back to this state, and now this, my maybe Jedi, becomes my best Jedi. This becomes my best Sith. I forget about that one and that one. And now, if the movie were to end, that's the one I would print. And I have transitioned back to the seen both because I saw a better, whoops, wow, that was, erase that, okay. I transitioned backwards here because I got a better difference. My pen's getting a little sloppy there. So I made that transition because I saw a better difference in the force sensitivity values. Now, what if, let's do one more. What if I had at time 9, I had a Sith with force 90? Oh, this one's better. I would just replace that one and I'd stay in the seen both state. So that one wouldn't cause a state transition, it would just stay there. Now, what do we do for these variables? Okay, so for an attack mode, I would need to know, okay, so remember this is on a per planet basis. So I'm going to need to know my best Sith time and force, my best Jedi's time and force, my maybe Jedi's time and force, that's 6 variables. And I would also have to remember which attack state I'm in, which state of my state machine I'm in. Now, how do we make a variable of that type? You could make it a string, except strings are slow to compare because you have to compare character by character to see if, like, if I say, like, if state equals double quote initial, if my state really is initial, and you say, are these equal? It would compare the lengths, because if the lengths are different, it's different. Then it would have to compare INITIAL. And every time, so that was like 8 comparisons, but for every one of those letters, I also had to check, am I at the end of the string? No. Let's increment an iterator or a pointer. Let's increment another one. So we're talking like 30 operations to compare 2 7-character strings. You could make them characters, which would be slightly more readable. You could make them integers, And you could look at my code, and my code might say, if the state is equal to 873,212, then do this. And that makes no sense at all. So we need a new type of variable here, enum. Okay, so enum class is more powerful than an enum, a little bit cooler, more C++y. So we could make an enum class like state. And then what we do, so that's the name of the type. We are creating a new type. It's like creating a struct, except instead of saying this is the collection of things it can contain, we are going to make a list of the values it can contain. So then we do curly braces, and then we could make a list of states like initial. I like to use capitals for things I create, because then it's impossible to confuse them with stuff that the STL created. So when I create variables, I do them lowercase. But for types, my types always start with a capital letter, so I always know it's a user-declared type. So I've got my type state. It can take on the new value initial, scene Jedi, scene both, and maybe better. And I'm going to make this generic because remember, I've got to do the same thing for attack mode and ambush mode. So they will have different variables, but the same idea. So let's just call this is the maybe better state. Let's keep it generic. Curly brace, semicolon. So then what I could do is I could declare later on, I could say, hey, I've got a variable of type state called state, and I set it equal to state : initial. So we have to say the type name : the value name. And then we can use it in ifs. Like later on, I can say like if, what would I be doing here? If my state equals state : initial. And then I could do inside of that, I could say like if the deployment type is equal to Jedi. Or I could even do something, I could go a step further and I could say, hey, because I read it in, right? I read it in as a string, but then I remember it as an enum. Like if deployment type is equal to side, don't select that all. Equals side : Jedi. I could have an enumerated type for a type of deployment. So I read it in as a string, but I remember it as an enumerated type. That one's not important. You don't have to do that. But you do want to do the states as an enum. Okay, last thing we want to talk about is ambush mode. Ambush mode is going to be a lot like this, except who you've seen first and scene Jedi. That scene Jedi isn't generic. Okay, so instead of scene Jedi, let's go back and change that. Instead of scene Jedi, because we got to make that generic, right? Scene, let's call it scene 1. And scene 1, right? So I've seen 1, I've seen the first one. Like in ambush mode, it would be that I've seen 1, I've seen a Sith. Okay, so that'd be a little bit more generic. That's better. Should have thought of that to begin with. Haven't looked at my code for this in a little while. Okay, so if we're doing ambush mode, we would still have the same, many of the same things. We would still have a state variable for ambush mode. We would have our best Sith, our best Jedi, time and force. But instead of our maybe Jedi for ambush mode, we would have a maybe Sith, force and time. Okay, did a lot for this. You'll have a lot to watch. I'm going to go find my window. Where'd my YouTube window go? Okay, so I'm going to finish this up and add some links to it. And I'll add some timestamps for where the interesting parts are. Good luck on the project.